Alright, we are asked to define WAEC number 12b in the theory questions. Now we're asked to find the distance apart from x and y. Now, the first point x is 70 degrees south, 5.70 degrees south and 60 degrees east. Then point y is 7 degrees south and 60 degrees east. Now, the first thing you want to do is you want to make sure you have your line of equator, equatorial line. Now, if you want to get your latitude, they say 70 degrees south. A better way of assuming it is, you know you can start from here counting 0 degree down to this place. If this were to be 90, then 70 will be somewhere around here, assuming. Then you could just pick a point. Nobody expects you to draw it to scale, but it will be closer to this down. So you have something like this. This could be your what? South, 70 degree south. Now, for your 70 degree, now we go to our 60 degree east. Now, east, you're going eastward. When we went south, we went downward, south. If it were north, we would have gone upwards. Now, east, you go eastward. If they said west, you go westward. Now, east, they said 60 degree. Now, for this east and west, it's allowed to go beyond 90. We could go 120, 170, but the most is what? 180. The same goes to west. The most is 180. But the north and the south, the most we get is 90. So we're going 60 degree east. So this is our east. So just going to take any line like that. So this will become our what? 60 degree what? East. Do we have that? Now the next point, we have our point X. We draw our point X. Look at the point X here. These are point X. These are point X. Now, where they both intersect. Now, 7 degrees south. If this were 90, like this, then 7 degrees will be somewhere from here, not too far from this line. So, if you want to do 7 degrees, you should look at something like this. So, I can, in that same way, mark this place with our 7 degree, not so far from the line. This could be our 7 degree. 7 degree what? South. 7 degrees south. Remember how I mean using. So 90, 80 should be closer to this line. 70 should be closer to this line. Then 10, 5, it should be closer to this other line. Then we're going down south, you're going downward. That's why I say 70 will be closer. 80 will be closer down here. So that's just the assumption. We're not drawing it to scale, we're not giving the actual measurement. It's just a map. Based on that. So this is going to be our point what? Y. Where they both intersect. You can see it. 7 degrees south, 60 degrees east. They intersect here. 70 degrees south, 60 degrees east. They intersect here. So look at where they intersect. Point X and point Y. We are asked to find distance between X and Y. So I want to do this. I want to clean these ones here. Let me strike them here. 70 degrees south. Because I don't want this complication here. Everything is coming out here. Then here is what? 7 degrees south. 7 degrees and 70 degrees. Now you understand why we have these two when we do the maths. The angular difference. So these are point X and point Y. We have to find distance from this point to this point. And remember, once you have you're looking for a distance along the what? The longitude. Along the longitude, you are going to use your big R. And our big R has a constant value of 6,400 kilometers. So we're talking from here down to this place and what here down. So we're looking for this distance from X to Y. And if you cut that shape out, you should be looking at something like this. And remember, the big radius, once you're looking for at the points along the longitude, your arrow has to be the major R. You're looking at the big R here, and you're looking at the big R here. This is the big R because it's from the center to any point. From the center to any point is the big R. But if you're looking for distance along the what? The latitude. Let's say this is the circle. You're looking for distance along the latitude. This is from this point to this point. You can see this is going to be small r and small r. We're looking for distance along this point. any point along the latitude, it will be small r, except you're using the equator, the line, the midpoint. It is only the equator that has the same size as this what? The longitude. All the longitude have the same size. All the longitude have. You can see, if this circle goes down, let me show something. Let me show something to you. If the circle, this circle here, the circle you create here, is not the same as the one you create here. So this one is bigger than this. And as you come to the, as you get to the midpoint, this one is bigger than this is bigger than this. Then the radius of each of them will be different. The radius of this will be bigger than the radius of this. The radius of this particular circle will be bigger than the radius of this one here. The radius of this one will be bigger than the radius of this one. So we have circle, circle, circle. Then this one at the center, you understand, will be the biggest of all the latitude. But this one at the center is equal to all the longitude. Let me show you the longitudes. The longitude are these circles here. The longitude are these circles here. They are all equal. They are all equal. All of them. They are all equal. So the radius of all the longitude. Okay, what I'm saying is the radius, let me make it bigger circle. The radius for the latitude. The radius, there's a circle at every point. And they have their radius. This radius is smaller, you can tell. Now if I make another circle here, the radius is going to be what? Smaller. If I make a circle here, this radius will be bigger than this. If I make a circle here as well, this radius will be bigger than this one until I get to the center, which has the largest radius. And the radius of the center is equal to the radius of the, and it is the big R. The radius of the center is equal to the radius of the longitude. Now for the longitude case, for the case of longitude, all the circles are what? Equal. And they have equal radius, the big R. So all of them, they are bigger. So from here, if you're moving to this place, it's still big R. From here, if you're moving to this place, it's still the big R. The big R is what we use. But you see this one, this radius differ related to the size of the circle. We have partitions to the size of the circle. You can see this part is smaller as it gets wider here. But you see this hole, for the large longitude, all the circles are what? Equal. Hence the radius is what? Equal. And that's the big R. So let's go get down to it fast. Alright, so we have this shape here. So we have a shape like this and like this. And this is the big R and this is the big R. Because it is along the walls, the longitude. Now, we know this place. From here, look at what I did here. This is the equatorial line. Now, let's do the math. From here to here is 7 degrees. Then from here to here is what? 70 degrees. So what would this place give us? It will what? Angular difference will what? 70 degrees minus 7 degrees, which is what? 63 degrees. Now, we know the formula finding what? Length of an arc. And we have to look from point X to Y. We know the angle is what? 63 degrees. Here is 70, here is 70. So the angle is what? 63 degrees. Have you seen that? So now, we're looking for point X. If there are cases where we have to add, but in this case, we're subtracting because we're looking for this particular place here to here. Now, point X to Y. Now we're asked to look for this distance. So what do we do? The formula of length of the arc. Theta over 360 times 2 pi. But our arrow was the big R, the capital letter. Remember, we're using the big radius. The big radius. Look at this. We're using the big radius. You see the shape here. The big R. That's what we're using. So theta is what? 63 degrees. 63 degrees over 360 times 2. Pi is what? 22 over 7 times 6,400 kilometers. And that is what we have. So let's work this out. If you enter this value in your calculator, what are we going to get?
4,740,800 kilometers.
Everything, what are we going to have?
Thank you, come
No, let's enter everything. 4 million. 1,000,000.
17,740,800 kilometers.
63 times 44 times 6,400.
Yes, that's 17,000,000
740,000
740,800
800
kilometers.
kilometers divided by 25 20. So divide it, what do we have in essence?
7040
7040 kilometers. So this is the distance apart from point X to Y. 7,040 kilometers. That's the distance.